your brown bag, please contact someone in the brown bag committee. So me, Viet, Ashik, Mark. So first up we have Kenny talking about TDD.
Oh, thank you. Okay, we're good to go? All right. Hey, everyone. I'm Kitty. If you don't know me already, you should. I'm one of the interns here at MYOB. So my presentation today is on test-driven development. But first, a little bit about me, if you're interested, I guess. Going into my final year at the University of Auckland, doing a conjoint degree in commerce and science. And my majors are accounting, information systems, and computer science. I'm also a part-time teller at BNZ during the year. And some things that I do in my spare time, just go to the gym and hang out with friends and play some computer games. All right, so test-driven development. This topic's actually fairly new to me. At uni, we're taught conceptually what testing is, but we never really do it. So it's just testing code, right? But at uni, we just learn about testing, but we don't do it. Okay. So the idea of writing tests instead of writing code was introduced to me when I first came here to MYOB. But it seemed odd to me because I'd never done any testing. But now tests drive my development. Let me explain. So first, some base concepts that relate to TDD. Most obviously, unit testing. This is testing at the smallest possible granularity. And feedback loops. We want to receive feedback quickly in order to respond quickly. It's pointless spending hours, days, even months on a problem only to realize at the end that our understanding of the problem was wrong. Collaboration. Software development is often done in teams. TDD can help facilitate collaboration when developing. And refactoring. Code maintenance is much easier for a developer picking up someone else's code when they have tests to validate functionality. So what is TDD? It's essentially a software development methodology which relies on a simple cycle. No code is written until there's a test in place. Once we have a test written, we run all our tests to make sure that the new test fails. This seems odd at first, but this actually gives us confidence to move into what's called a red-green refactor cycle, where we know we're doing something right, both when tests fail and when they eventually pass. Now we write the code to make the test pass, but we keep it simple. We do as small as possible, the minimal amount of work. Oops, did I just end it? Okay, now we run the test again, and we check for our green light. We're not done here, though. We need to refactor. This removes any duplication and increases maintainability of our code in the future. I feel like this would be more clear with an example. So here's a simple coding kata, which will be the context for our example. Basically, we output depending on whether the input number is a multiple of 3, 5, both, or none. So there's an example output on the side, which is incomplete. Okay, so we start with making a test. So I've written this test here, which basically makes the assumption that our code exists, but it actually doesn't yet. We haven't written any code. This test will obviously fail. We can't even run it because it won't compile. Okay, but now it gives us a direction in how we're going to start. So we run the test. Nothing happens, obviously. Now we write our code. We do the minimal amount of work to make that previous test pass. So we have this. We give it the number 3, and all we do is return fizz every time. We run the test, and it passes. We're done, right? No, we've still got the refactoring. So this is kind of like the first iteration of this cycle, and you just keep incrementing on that and improving your code. So now Obviously, our code doesn't work as we wanted it to for the kata, but it does pass the test. So maybe we should test a little bit more. So I've added a couple more multiples of 3 here, and this actually passes as well. But what if we were to give it, say, 15, for example, or 5? We'd be expecting buzz or fizz buzz, but it'll always return fizz. Okay, so this is where the refactoring comes in. Obviously, it fails our requirements, so we need to change it. So I've added a new test here, and our expected input is a multiple of 5. So we're looking for buzz as the output. And surprise, surprise, our test fails. So now we do the minimal amount of work to make our tests pass, both the original test and this brand new one. So now what we have here is checking if it's a multiple of 3. If it is, then we return fizz. If it isn't, then we return buzz. And success. But still, we haven't gotten to the fizz buzz stage. But this example just demonstrates the power of TDD. It gives you direction in terms of where you're going to go with your code, what you're going to do next. It's a confidence builder. You can keep iterating on your code and keep it simple. And that's all for today. So any questions? Mark.
So this was a new thing for you?
This was a brand new thing for me.
Have you tried it on things other than katas?
Yes, I have, because we've actually been developing our own project as well.
And how are you finding it?
In my experience, I feel like I haven't done enough unit testing to get the best out of it, but I do try and start with some tests to get me in the groove of developing something new. I do find it's hard to kind of write a test that's very specific, or say a function does something other than return. For example, like if you're mocking an input or an output, then I find it can be a bit difficult, but I guess it comes with experience. Does that answer your question?
Yeah.
Any other questions? Yep.
You spoke about that refactoring step.
Yeah.
What do we refactor our code that we have implemented?
Yeah, so that generate, sorry, I'll go back. That generate function's actually changing as we go. The first iteration, we only accounted for the fizz step, and then we're kind of changing it to account for more and more on top without breaking the previous steps.
During the process, at any time, do we refactor our tests?
So I did actually change the test slightly, but it's kind of like it's like a push and shove. You need to change as you go, but it's an iterative thing. So as you think of something new, then you go back and change.
Do you see benefit in doing TDD?
I feel like the confidence part is a good thing, but also when you're coming back to code and you've made a change and say your test fails, then you obviously know something about the functionality of your code has gone wrong. So you can go back and have a review of what you wanted to change, and then maybe make some adjustments and then see if your tests pass again. Yep, Saish.
Would your test change the implementation of your code design?
Yeah, I guess that's kind of where the test-driven development thing comes in. I feel like it does make your design a bit more simple, and you kind of, before you get to the stage of needing to extract out so many things from one super behemoth of a class, you've kind of already thought about the smallest pieces, and in that way you've already got small pieces of code. So I guess it kind of gets you to think about your code more granular to begin with before you even start. Any other questions? Nope. I have a thank you slide.
Thank you, Kenny. So I just have a question to give out. We have some stickers to give away, GitHub stickers. So I'll give you after everyone's done. What was the kata that Kenny used TDD on? Oh, next. Nice. Give me after. Who's up next? Sean? Okay. So next up we have Sean talking about, was it naming? Variable naming. Well done, Sean.
So this goes in
do you put
just
this?
USB. Oh, I just put it in my backpack like that. Yeah. And then there's the clicker left, right. So just plug that in.
Wait, why do you need to plug that in? Oh, for the
Your
clicker.
clicker, yeah.
Right. Thanks, homie.
Oh, thanks, man.
You don't
I
deserve
love-
a welcome.
I love the compliment.
Testing. Hello? Does it work? Isn't it? Oh, okay, my bad.
Just for the video, just to look cool.
I knew that.
That is being recorded as well.
Oh, no, I don't look cool anymore. Stop giving me good advice. Give me a second. All right. Hey everyone, I'm Sean. I'm currently an intern here at MYOB. I'm also known as Huffer Boy, Scaby Boy, and all the other words that they call me. Lady Boy too. Yeah, I'm also the best intern, as I'm sure Mark will agree. Yeah. And today I'm going to talk to you all about revealing intent.
You're one of the top 4 things.
Oh, thank you. I'll take that. Now, revealing intent is definitely a topic I'm very happy to talk about because it's something that no matter how long you've been developing, you're still working on and you're still trying to perfect. So it is widely estimated that developers spend 70% of their time trying to understand code during code maintenance time. Now, this is wasted time for a developer, and in turn, the company will lose money as a result. As developers, we should be thinking to ourselves, how do we reduce this? One solution is revealing intent. Now, what does this actually mean? In programming, revealing intent is exposing the purpose or intention of our code. That means when you see a piece of code, you know exactly why it's there, what it's used for, and why it exists. But how do we actually do that? Let's take this piece of code, for example. Can anyone here tell me what it's actually doing? Nick? Yes, what does it do?
Square root approximation.
You're a cheater. But you wouldn't normally know that unless you were obsessed with math. You know, if you were coding on a development team, that's not fair to your other teammates because they would look at that and have no idea what's going on. So now we have to ask ourselves, how do we reveal its intent? How do we show other developers what it's actually doing? Let's add a comment. Comments are good, right? Mark? And with a comment, you can actually see what's happening. You now know what all those what those lines of code under the comment actually mean. So the intent, yeah, it all makes sense. So is intent now revealed? Everyone?
I'm going to say no.
Well, I mean, it's yes, because the intent is revealed because now you know what that code's doing. And that it is revealed, but is this the best way to go about it? Let's try an alternate. Oh, sorry. So comments are actually a double-edged sword. Oops. Give me a second. Sorry, comments are inherently neither good nor bad. However, if you use comments to reveal intent, then comments become like more code to maintain. Every time you change a piece of code, comments associated with it also have to change. However, there's no inclination whenever you change functionality of code to change the comments associated with it, because your code will still compile even if those comments don't change. And when comments aren't maintained, they become dangerous. Because now you have comments saying one thing while the actual code is doing something else. So we should avoid this if we can. So let's try an alternative. Let's try and write code as if comments just didn't exist. So let's take our original example, and now let's try and reveal its intent without adding a single comment. So we extract it into a method with an appropriate name, and now without using a single comment, people can understand what it's for. Obviously, there's more that could be done. Instead of n, we could have called the variable number, but this is a very, very good first step. When you write code with no comments, you'll be forced to write your code in the simplest, plainest, and most self-documenting way. This will allow your code to tell the story, and it should be doing that. Comments should not be there to tell other developers what your code is doing. Choosing good names takes time, but it saves more than it takes. So now the natural question is, what is a good name? A good name is one that obviously reveals intent. Now, what I mean by this, a name should explain why something exists, what it does, and how it's used. If a name requires a comment, you probably don't have the right name. Let's look at an example of this. So let's look at this variable, int d. If that comment wasn't there, you would have no idea what it was there for. D reveals nothing. You don't know why it exists, what it's used for. Instead, we should choose a name that specifies what it's for. So as we see with the comment, elapsed time in days, why don't we choose a variable name which specifies what is being measured and the unit of measurement? And just like that, we removed the comment but revealed the intent. The same thing can be applied to methods. So this is a method from Minesweeper, from a Minesweeper context. Now let's do it again. Can anyone actually tell me what that method's doing? Nick?
So
You're a cheater.
if the first number
Yep.
in a list is 4, then you increment this.
Okay. But what is the list? What's stored in the list? What's the significance of the value 4? These are questions that shouldn't exist if good variable names were picked. So let's pick good variable names. And now in the Minesweeper context, that's pretty clear what it's doing. It's looking through all the cells on the board, and where any cell is flagged, it'll simply add them to a list and return that list. John F. Woods says it best. Always code as if the person who ends up maintaining your code will be a violent psychopath who knows where you live. Code maintenance is the most expensive phase of any project. And as developers, we should be striving to reduce this cost. And one way we can start is by using names which reveal intent. Questions? Anyone? Yeah, what's up?
Where do you live?
Where do I live? 13-bit, no, okay.
Was this used to you, or is this a concept familiar past?
Yes and no. It was always there, but at university it was just a lot easier naming a list, and then writing a comment. The list stores cells rather than just calling it cell list. So definitely it is a new concept, and it's one that I'm really, really trying to do everything I can. Even the little things like not using abbreviations or anything like that. I just want to be as clear in my code as I can be.
There's a good blog post by J.B. Rainsberg where he talks about the different stages of naming that I think would really fit in well with revealing intent. Because I think like getting to a good name is really hard.
Yeah.
So
Yeah.
I really like what you're saying, that there's a lot that you could build with.
What's up?
Just on Mark's point about like is it a focus at uni? I actually had a few assignments where if you didn't have comments, you would get marked down.
Oh yeah, 100%. I had that as well. So what we would do at university is we'd write our code, and then we would just add in comments, just so we wouldn't get marked down. So
You can even have just the comment sync.
yeah,
Just need to be there.
yeah, it just had to be there. Yeah. Yeah, it does. It does. It does.
Oh,
Yeah, what's up?
now that you've seen the benefit of revealing intent, do you think going ahead you're going to be like some sort of advocate for it at uni or?
Yeah, I'd say I already have been an advocate. I mean, you know Nick, not this Nick,
The real
but you know other Nick, and yeah, I told him about it, and we code together, and he doesn't write comments anymore. So I've converted one.
He's gonna get marked down.
Not my fault.
You failed. It's failed. Blame on
Yeah.
Any more questions? Okay.
Can I answer this question?
Sean? No. You can answer the next one. According to Sean's presentation, what percentage of time do programmers spend reading?
70%.
Ah.
You can collect a sticker from me.
I don't know.
Okay. Next up we have. Oh, good. Next up we have Lilia. Teaching us about composition versus inheritance. Give it up to Lilia.
Oh, okay. How do I get this to connect? Sorry? How do I get it to connect? Yeah. Do I have one of those touch bar things? Try like unplugging it and plugging it in again. No. Maybe it's. Oh, yeah, that's how you do it.
Oh. Oh, yeah, don't you put
Sean said he might despise heck.
His password is going to Sydney.
All right, hi everyone, I'm Villia, and today I'm going to be talking about composition versus inheritance and how we can build better code. So first, let's establish what is composition and what is inheritance. So composition is when you have in a class fields that reference other objects. Essentially, a class uses another class to implement part of its functionality. And the purpose of using composition is to build wholes from other parts. For inheritance, this is when a class uses by default methods and fields from the superclass. So these methods and fields can be overridden, but I would say that one of the essential parts of inheritance is that is that it arranges concepts, it arranges related concepts from generalized to specialized, and it also tries to capture the mechanics of how the different classes work. So if you ask someone, which is the better solution, which is the better option to building better software solutions, you'd probably hear a lot of people saying to favor composition over inheritance. Now, this is great as a general rule, but it's really important to understand what the reasoning behind this is. And as with anything, there are no silver bullets, and you can't just blindly follow a mantra just because people tell you to. So let's now explore why people say that composition is the better option, what some of the drawbacks to composition may be, and what some of the situations, what are some of the situations in which you may find that using inheritance is the better option. So firstly, one of the large benefits of composition is that it leads to solutions that are higher in cohesion and have less coupling. Composition-based solutions tend to break up a problem into distinct responsibilities, and the implementation of each of these responsibilities is encapsulated into another object. This is really great because it means that you have classes that have higher cohesion, and all the separate components of these classes work together to contribute to a single well-defined task. Since all the more complex functionality that you want to build is built by assembling different combinations of the relevant objects, and these objects all interact with each other through a public interface, this also encourages coding more to an interface rather than an implementation. And it means that composition-based solutions tend to be more heavily reliant on polymorphism rather than their inheritance-based counterparts. As it encourages coding to an interface, this also means that you are better able to handle situations in which you may want to pass an object to as a parameter to a method where the object has a different implementation but the same interface. Now, solutions with high cohesion and low coupling are more testable and allow for quicker feedback loops. This leads to code that's more maintainable and responds more easily to change, which is really important for software in a business, because to a business, what makes good software is the value that it can bring to the business at that particular point in time. So a business has more of a competitive, So a business has more of a competitive advantage if they're able to respond quickly to the changing demands of their customers, and having more maintainable solutions and code that responds more easily to changes means that this is what the better option for a business is, and composition-based solutions help a business achieve that. However, some of the drawbacks to composition can be that it can add more indirection to a system, and it can also require more work to achieve the desired behavior because it involves assembling all the different components, and that can just sometimes take more time than if you just inherited a different class and added methods or whatever you wanted. Sometimes the cost of constructing a system using composition is greater than the benefits that you would get from having the encapsulated responsibilities and the more flexible functionality. Sometimes your object may already have a single responsibility and you just want to add specializations to that object by adding some additional features. So it's all augmentation rather than taking away features from it. In these cases, if you used composition to achieve this purpose, you can sometimes find yourself only having one component that brings most of the functionality to your new object. And then you can find yourself making follow-through methods to call the methods in that one component, which means that you essentially create a wrapper for your object. And in these cases, sometimes it's a better solution to consider inheritance because that better reflects what you're trying to do, which is create a specialized object. So while inheritance certainly has its drawbacks, that's not to say that in every situation, inheritance is terrible and you should never use it. It all depends on what your problem is, and the right solution to that problem will be different depending on that. So some takeaway points that I'd like to bring is that as a general rule of thumb, using composition over inheritance is really great, and it applies in most situations. However, if you want to bring the level of the software solutions that you build higher, if you want to bring a better solution, it's really important to understand where these ideas are coming from. And by understanding that, you can better figure out which solution or which tool is the better one to use for your particular situation. Thanks. Are there any questions?
Have you tried to solve a problem using composition? What was your experience with that?
Yep. So for my katas, I don't think I've ever really used inheritance for them. And I found that composition is generally the better approach for them. Yeah. I think these days it's probably a lot harder to find situations in which inheritance is definitely the better option. And yeah.
Yeah, so I totally agree on your point that there are some instances where inheritance makes sense.
Mm-hmm.
Like the one that I can keep thinking of is in test classes, if I'm making a specialized test class,
Mm-hmm.
like I'll use inheritance to leverage that. But like 95% of the time, I do composition.
Mm-hmm.
Is that all the questions?
Oh, one more.
more.
If a new intern, so in the future, if you end up mentoring
Mm-hmm.
and you mentor an intern, what would you make them do to kind of understand the difference between inheritance and competition? What's the difference?
I would direct them to a few blog posts that I think explain the concept really well. And there's also this kata in the general developer repo, which is called composition. And basically, you implement the same class using both inheritance and composition. And then that way, it's really easy to compare and contrast what some of the benefits are and what some of the drawbacks may be.
Okay. Thank you, Julia. Quite good. So the question for this one is, who can give me a drawback of composition? Sean.
Take longer.
Yeah. You can
Stuff is a real.
Oh, and
Really revealing it.
yeah. Next up, we have Jono talking about coding katas. Yeah. Give it up for Jono.
Why is it doing that?
You want one?
Command space.
Space. Display.
Command space.
We want it display. Wait, hold on. I know what this is. Wait, where would I go? Arrangement.
I go display and then just click the best for Samsung.
Yeah.
Just click best for Samsung.
Oh, my bad. Yeah, I just saw that. All right.
That works.
Ah. So tiny. Dude, where's my mouse? Oh, here. Ah. There we go. Oh crap. Yeah. No. Don't read this, guys.
See, wait, what wasn't doing it?
This is informal.
Wait, how do I set this up?
Plug it in.
Plug the mic
Plug the mic in.
in. Yeah.
Oh, you mean like? It's like I was like looking at my laptop, like, am I meant to like plug this in somewhere? You guys just kept it here. Is that what it's?
I think the intern.
Plug in the receiver for the clicker. The clicker has a receiver on.
You should take off your tag.
Hey, Johnny, you got one straight here.
Where's my mouse again? Oh, here.
Just click the X.
Sup, guys? I'm Jono. I like skateboarding and making stuff, and I'm an intern here at MYOB. We're leaving next week, which kind of sucks, but we're all here today, which is great. So, so I like to start off my talk with where the talk originated from. Mark told us all to come up with topics to talk about in our lightning talks, and I said coding katas. And then Mark, being Mark, goes, "Oh, so what about coding katas?" And I was like, "Oh, I'll just talk about the history behind them, or why they're really good for you." And then Mark hits me with this, adhering to his position as the Plato of my life. Why not talk about an intern's perspective on coding katas? And yeah, being the best intern I am, I'm like, oh yeah, easy peasy lemon squeezy, got you, bro. But deep down, I was like, I'm an intern. I don't have an opinion. I don't know what I don't know what to think. But yeah, today I'm going to be talking about an intern's perspective on coding katas. So to begin with, when you ask an intern their opinion on something, any intern would the first thing any intern does is Google what other people's opinions are. So that's what I did, and I came across a few gems on Reddit. The first one by Roomba here. I effing hate this term simply because kata are the most useless training system known to man. Code kata would be if you retype someone else's code. Now, yeah, obviously this guy just hates katas, and I feel like a lot of people here are probably against this perspective, but we'll come back to this. Another gem I found was, 11 years ago, you know what's about that. 11 years ago, it changes. Okay, chill out. The next gem was skinny arms. Because the people I've met who do code katas after work and on weekends are some of the most driven programmers I've met. They are pushing themselves by experimenting with new techniques and ideas to improve their craft. I've yet to meet someone who just does katas. And I feel like a lot more people agree with that statement. But yeah, so these are two very contrasting opinions. So let's first analyze the first one, Roomba. What we can take from Roomba's statement was that kata are the most useless training system known to man. So it might help to know what katas are. Katas are, in karate, a way to practice and hone one's skill. So imagine yourself constantly practicing a karate chop, doing this thousands and thousands of times. And that might not seem like a bad thing. Practice makes perfect. But there's a catch. And if that's not obvious with the karate chop, I have another example. Imagine you want to be the best musician in the world. To be the best musician, you would have to know the theory of the music, the mechanics of your instrument, and also it might help to have some talent. But yeah, of course, going back to practice, practice makes perfect. You have to keep practicing your music. The only thing is when you're practicing music is that you get feedback. You have someone teaching you. You have a mentor providing you feedback on your mistakes. That's the way you learn. So going back to the karate chop, imagine a burglar breaks into your house one night. You come face to face with this burglar and he throws a punch at you. And yeah, after thousands of hours of training, you fling your arm with 1,000 strengths of 1,000 suns at this burglar. And then you get up the next morning in the hospital because you didn't practice for an actual fight. All you did was fling your arm in the air 1,000 times. So yeah, practice makes perfect, but feedback is important. And if you don't get feedback, and if you just keep flinging your arm, you're just going to develop bad habits. You're just going to fling your arms at the wrong time. You're not doing something that's productive. So I've analyzed this perspective. Let's move on to skinny arms. I've yet to meet someone who just does katas. And that means a lot, So just doing katas, as we've previously discussed, isn't enough. You might develop bad habits. So, sorry. Develop bad habits. Sorry, is there if I just quickly like? I have pretty good eyesight, so yeah, it should be fine. Yeah, going back to this, sorry. So yeah, feedback was really important before, and that was because you need to make mistakes. Mistakes are how you learn. So the reason not just doing katas was really bad was because you kept making the mistakes and you didn't get feedback. But if you do get feedback, you can start delving into the benefits of katas, experimenting, trying out new things. You can't try out new things in a production environment because that actually matters. Money's involved. You have customers that are going to bite you if you don't do what they want you to do. Also improvement, looking for a better solution. Relax. Okay, custom mark was a bit aggressive. So, looking for a better solution. After your experiment, you might succeed at something. You might find some new solution that you could take to your development environment, your production environment. So application, bringing what you've learned into an actual scenario. So let's review these two perspectives. Katas are useless by themselves, as we can tell, because they inherently don't just have feedback. You require a mentor or someone to talk to receive feedback. And they're also a good time to experiment and try new things. And the two goals of katas are to gain good habits and to also apply what you learn. They're an opportunity to learn new things. So yeah, enough talking about these guys' opinions. Let's talk about my own. So there's a reason I compared Mark to Plato earlier on, and that's because throughout this internship, Mark has questioned me and the other interns, I'm pretty sure I speak for all the interns here, about the way I code and also the way I talk or discuss my ideas with other people. And that whole examining of myself kind of reminded me of Plato's novel, Plato's Apology. And the famous quote from Plato's Apology, "The unexamined life is not worth living." Ooh, deep, whoa. So directly relating this quote back to coding katas, it might be important to ask ourselves, if you're not willing to examine your coding, is your coding even worth it? Now, that's a pretty heavy question, but it has hopefully a really obvious answer. No. Code that doesn't have value just isn't good code. So I think it's about time to fuse all of this together. Let's bring it together and let's talk about my perspective. How do coding katas relate to me as a person? So when I think of coding katas now, after my internship and after doing some research, I guess, it reminds me of jogging. So the reason I bring up jogging is because it's also something else I've recently gotten into. At first, jogging, I saw your Instagram post, hey, good job. Jogging to me is, well, at first was really scary, you know? Looking at jogging from like a noob's perspective, it's something that brings a lot of pain. You know, when you first go for your first run, your legs hurt, you feel tired, and that makes you really afraid. But the more jogs you do and the more runs you do, over time, that pain fades away until the run you do becomes seamless. That pain is something you enjoy. But the same thing can be said about coding katas. Coding katas, the way you receive feedback with coding katas is by getting your mentors or your friends to read your code, to roast your code, to make you feel like an idiot. But Yet's laughing because he knows he did that to me. It's just, but yeah. Oh, that distracted me, bro. Yeah. Yeah, that feedback is scary at first. I remember the first kata I did in this internship was the tic-tac-toe kata. And at first I was really like nervous to show Kathleen and Viet my code because I knew, obviously, that I was a lot more naive than they were. I knew that they would catch me out. I knew they would point out that I wasn't following the 4 rules of simple design, that my TDD was disgusting. I don't know, just all the bad things about it. But just like jogging, over time, that pain doesn't become a pain anymore. It becomes the point of the kata. It becomes what makes a kata so good. You learn from your mistakes. That negativity becomes a positive thing. So I'd like to finish off with this. I think coding katas are good, in my opinion. Or rather, you should only do coding katas, in my opinion, if you have a personal drive to make yourself a better coder. If you have thick skin when people roast your code, if you just can't take it, then don't bother doing a coding katas. And you also have a curious mind. You should want to try new things. And with this, if you don't have these 3 things, or if you just don't have the time to do coding katas, it's okay to not do them. Coding katas, just like jogging, there are other ways to stay fit and to make yourself a more fit person or a healthy person. And just like that, there are other ways to make yourself a better coder. You don't have to just do coding katas to make yourself a better coder. If you can, that's great. If you can't, you can't. So yeah. Thanks. I mean, you can, sorry.
So you've done a few katas during your time here, right? Have you ever done one kata more than once and reflected on how you've done it different from the first time?
Yeah, so I've done the tic-tac-toe kata twice. The first time around, like I said in the speech, was really eye-opening, I would say. Like, you realize how much uni didn't prepare you for work. But the second time around, I didn't get Viet and Kathleen to look at it. Maybe because I guess we got our main project and it didn't become as important anymore. I probably should have. But I definitely saw myself analyzing myself and my code a lot more. I definitely found myself rather forcing myself to follow the 4 rules of simple design, or catching myself out oh, this is so stupid. There's something wrong with this code. I should be doing something here. And yeah, I just found myself questioning myself more. Yeah.
What other katas have you done?
Game of Life, Roman numeral kata. Yeah.
And which one have you enjoyed the most?
Game of Life. Pretty cool.
Fist buzz.
I haven't done that one yet, probably. Put that up.
Any more questions? Okay, thanks, Donna. That was very creative. Thanks, interns. The question for Donna's presentation is, what was the name of the Reddit user that was quite negative towards
Rumble.
Oh my God. Yeah,
Raise your hand.
I already have many seconds.
Who is raising their hand? Wait, Sage, you had your hand up.
Oh, it's broken.